Welcome to Revolution Against Evolution. I'm your host, Doug Sharp.
Rich Gear here as well, and we're going to talk about something we haven't really talked much about. And we're from the state of Michigan, and we're talking about Michigan geology and flood and glacial and all kinds of cool stuff. Dating issues. What's the name of the show, Doug?
Michigan Geology from a Creationist perspective. And what we want to do is to talk about something that sort of fits the evolutionary model and the creation model, but you have to take the data as it's presented and what you find in the rocks, and then interpret it according to the paradigm that you're
your worldview, right?
Worldview, and that's really what it is. We're looking at the same evidence. The evidence isn't any different for the creationists as it is for evolutionists.
Rocks are rocks, fossils are fossils, and we've said that for a long time now, and all creationists would say the same thing. It's really how you look at what you're seeing, because we have to judge from the present. We weren't there in the past, so whether you think it happened many thousands or even hundreds of thousands of years ago or millions, or whether it's just a biblical time frame of around 6,000 years, depends on how you think things happen. Now, there are things you can infer. You could show things in the present that kind of give credence to your interpretation, i.e., we've talked about many times the Spirit Lake and the how fast the sediment built up in that canyon there, that 1/40th the size of Grand Canyon in just a course of a couple of days,
Right, so you can see the tremendous power of water action that took place.
So that you can extrapolate that into Grand Canyon. That didn't take hundreds of thousands or even millions of years necessarily to go. So Doug, where did you want to start with this?
Well, Michigan is very unusual in the way that the geology is made up. The top layers are all what they call quaternary, which is the glacial, recent glacial geology, and they date that somewhere around 10 to 14,000 years ago.
Sure, yeah. Mm-hmm.
And so we already have a contention with that, but and we'll get into that a little bit later. But underneath it, you have the bedrock geology, and that's very unusual. What is called is the Michigan Basin. And you have the youngest rocks in the middle, and as you go out in the concentric circles, you have successively older rocks going on out, to where back up in the Upper Peninsula, in the Keweenaw and the Porcupine Mountains area, you have what they call the Precambrian rocks.
Okay.
So
we don't have those down here in the lower peninsula. No, down here.
You will have some of that going over in Wisconsin and in Ontario.
Okay.
But what you then had was the glaciation that took place over the top, which actually carved out the Great Lakes. And it's interesting that if you take a look at the lake beds of like Lake Superior and Lake Michigan, you can see some of the striations in the rocks in the bottom of the lakes that look sort of like the Finger Lakes in New York, which they're long, skinny striations like that. So it does indicate that the glaciation took place north to south manner and then receded.
Okay.
And there was actually some uplifting that took place as well. And you can maybe argue that the uplifting took place before or after the glaciation.
Oh, really? Okay. So the uplifting maybe.
So they really don't know when that uplifting took place.
Now, from Crazy's point, the glacial time, the ice age, if you will, is really post-flood.
Right, yes.
Okay? And so that would be, 2,500 years ago or so. And so you're talking about, obviously, from a creation standpoint, all these time frames are much more truncated.
Right.
Even though the secular position has it not nearly the millions and billions, although with Precambrian they would. But you know, you usually think people are dating things 10 to 14,000 years ago, and for a lot of stuff going on. But it's still a lot longer than the biblical time frame, which would have been just about 2,500 years ago.
Well, let's take a look at the origin of the glacial dates, which Mr. Lyell was partially responsible for. What he did was he visited the Niagara Falls.
Oh yeah.
And you know, Niagara Falls, he was observing that they were receding at a rate of about 4 feet a year. And so he then applied his principle of uniformitarianism, which I call uninformitarianism, which is the idea that what the present, what you see happening in the present, is the key. Has
always been,
And so he didn't allow any room for a flood. So what he did was, he, over the course of what you would say 11,000 years, I think it was, for the Niagara Gorge
to eroded to the point he was looking at it.
Now, what was interesting though is that he probably wasn't aware of Father Hennepin's drawings. Father Hennepin was the guy who visited Niagara Falls as a French explorer and determined, well, this isn't going to be a very good navigation route here.
Yeah, he was, what time period was he?
1677.
Yeah, he was the late 1600s. Yeah. Lyell was early 1800s. So you're talking 200 years. Right. His drawings look remarkably and significantly different than what Lyell would have seen. Is that correct?
That's right,
and his assumptions were basically erroneous, is what you're going to do. How much?
What I'm saying is that even with using the time scale that if you take into account Hennepin's drawings, the time scale would have been much faster because the gorge would have been narrower, and you would have had a much faster erosion taking place through the gorge during those 200 years.
Do we have those drawings, Doug?
Yes, we do.
Yeah, good. We'll show them. Yeah.
So those are pretty cool. I like to actually show them to people in the museum when we talk about the French.
Oh, yeah. Yeah, because the French you knew, yeah.
The French knew that, but they knew that they didn't want to go the way of Niagara Falls. So when they traveled to Lake Huron, they actually going up the Ottawa River and portaged across the spot to Lake Huron. And so I think there's Frenchman River there in Ontario that they can get into the. So the voyagers took that route. Let's take the standard evolutionary geology, where they've identified the rocks, the bedrocks in Michigan in this circular pattern. And it's interesting how many different types of rocks there are.
Okay.
And they classify it by their formations, by the types of rocks and by the maybe the fossils that are in them. Some of them have fossils, some of them don't. But each, there's a scale for Lower Peninsula, scale for the eastern half of Upper Peninsula, and a scale for the western half. And each of these scales shows 20 to 25 different layers. Now that, if you're trying to apply that to the standard geologic time scale, at the bottom you have Precambrian, then Cambrian, then Ordovician, Silurian, Devonian, all the way up to the... there's only maybe 10 of those or 12 of those layers, but so you have to pigeonhole some of these all in the different same scale, or it'd be the upper Cambrian, the middle Cambrian, the lower Cambrian, and so they're scaling it according to way that they thought it was laid down over those periods of millions of years. But we can also interpret this in the creationist sense by saying that this basin that was there was filled in rapidly with these different types of rocks. And you see this there's an article that I was reading here called
Would it be through flooding action?
It'd be through flood action. And this article is called Thundering Burial, and it's talking about the fossil beds that are in the northern Lower Peninsula, near Alpena.
Thunder Point or Thunder Bay? Or?
Yeah, Thunder Bay has actually 3 points. There's the northern point of the bay, and there's this middle tip that's
Kind of juts out?
Juts out.
Yeah.
What is the name of that? It's called Partridge Point. Partridge Point actually shows a barrier between several different kinds of rocks. And then there's the southern part of Thunder Bay, which we saw at Neglegun State Park. But the Neglegun State Park was on Lake Huron, and it's it's a beautiful stretch of beach on Lake Huron.
Why did we go there?
And we went up there and saw those Indian mounds up there. Remember that? I went with Dan Jansen. Maybe you didn't go with us.
I don't think I went on that. I don't think I. In fact, I remember you were going on that. I couldn't go. That's right. So that's why I didn't remember that. Yeah. So anyway. Yeah.
All right. That was a long time ago. So 2006 or so.
Yeah,
That's
yeah.
about 13 years ago.
Yeah.
Can you imagine that?
Yeah.
My goodness. But if you want a real unspoiled wilderness, a place to go hiking and I think there's some camping spots there, rustic camping spots there now. And you want to visit a beautiful beach and go there in maybe the summer or fall.
Yeah, that would be beautiful.
It was just amazing.
There's Indian mounds up there, huh? What do you know? What do they know? What tribes they are? Are they Algonquian or Algonquian?
We're really not supposed to know about them.
Oh, we're not. Okay.
No, sorry.
You blew it.
I blew it.
You blabbed it. How come we're not supposed to know about them?
Well, they don't want them disturbed.
I don't want that. That's fine. But okay. But so by and large, but Doug, this article talks about this limestone, and there's all kinds of fossils in this area.
Right.
Yeah. So and with the fossils, of course, they're mainly brachiopods and crinoids, and basically things that lived underwater.
And they're all jumbled together.
They're all jumbled together in what we call a fossil graveyard.
Right.
So, and interesting about these fossil graveyards, you think about them with the dinosaurs and stuff. Michigan has never found a dinosaur, as far as I know. There's never been a dinosaur. There have been mastodons and mammoths found, primarily mastodon, but we have some mammoths here. But those have been, and I don't know. I don't know when they were living here exactly, but they were buried and fossilized probably during the glacial times, I would guess. But they were here before that as well,
And in the museum, it shows that they were here along with people. People hunted them.
Oh, sure, yeah.
And so these are not something that were prior to man being here. In that sense. They fit within the biblical timeline.
They do. And what's funny thing in the museum for a long time, Doug, so the museum was a different department than the DNR, okay? Mm-hmm. So their provenance was human history only. Mm-hmm. So they couldn't really show a mastodon or a mammoth unless they had like a Clovis point. Yeah, right. But now it's all one big happy family, so natural and human history can be combined. Mm-hmm. And so the museum has a new display in there, fairly recent, and it's got some mastodon, talks about it. But yeah, the idea, they've always known that humans and mastodons and mammoths have been around together. If you ever saw a Clovis point next to a T-Rex or something, that'd be something that's really would mess them up badly. But this so far, you're you're not so much. But their biblical time frame, even they're closer, Doug, but they're still, you're still talking about 10 to 14,000 years ago. That's a standard ice age time. Whereas again, the creationists would be more like about 4,500 years ago, you know?
And so you have this basin, but it's sheared off completely.
Yeah, and that would have been done by the glaciers?
I'm saying this is flood.
Oh, flood, okay.
The flood shears it off because you have all that massive retreat of water coming off.
So it was built up during the flood?
Yeah.
And then the retreating sheared it off?
And then you would have the glacial cover come a little bit later.
Create all the striations and all the different things.
Right, exactly.
The moraines and yeah.
Yeah, now a moraine is a buildup of glacial till, which has a lot of coarse gravel in it.
Yep.
And if you go up north on US 127 past Clare, we always look for the big hill. And the big hill is actually a glacial moraine. And you can see as you go up the hill and go up over the hill, all of a sudden it goes from farmland to forest. Because you got the finely grained sediment down below the hill, which is the farms, but up above it you have the coarse stuff.
It's kind of when you're going up north, you hit that thing up there north of Clare. Suddenly you're out of the south, you're in the north area. There is a moraine and an area down in the southern part of Michigan too, or the Calhaven Trail. It's all that whole area where Kalamazoo, South Haven, or Grand Haven. I'm sorry, the whole
Well, if you take a look at this glacial map, it shows you how it actually curves around. It sort of follows the Saginaw Bay and it hits that area, and so you'll have that moraine go around, and you see the moraines down in the Irish Hills area.
Oh yeah, we've been there too.
And you find the things called a came, which is a hill of glacial till, and then you have an esker, which is where you have water running through the glacier, and then it creates a stream, and the stream brings with it the sediment, and it builds up this coarse gravel in this esker. And eskers, once you find them, they're a good spot for mining gravel.
And there's little kettles, little thing where they got, what is that though? That's like a...
Well, that's where you have a block of ice that's covered with sediment. And then the ice melts, and you would have what's called a kettle lake. And so you got this little depression right here.
Right.
And it will fill in with water. And if you go down to like the Glacial Geology Center down Geology Glacier Center in Waterloo Recreation Area, there's a kettle lake that's starting to get covered with a lot of and the vegetation is taking over the lake and covering it, and underneath it you're getting some of the sediment coming in, and so it's going to gradually fill in. And there's some lakes like that up in the Alpena area as well. And then it's actually part of that same formation that's curving around from one side of the Michigan to the other, and like up there near Atlanta, Michigan, there's a whole series of these between Atlanta and Alpena where there's all these kettle lakes. And you may remember McCormick Lake when we were up at Lewiston. Yeah. So that was a kettle lake.
Kettle Lake? Okay, yeah.
And because if you take a look out in the lake, and just off the lake edge, you can see the drop off. It just goes right down. It's 50 feet.
Yeah, some of these kettle lakes are pretty good size.
Yeah, they are, and they're very deep. And they're spring fed, and so it's
pretty cold.
Yeah, pretty cold. But some of them are up there are covered with vegetation as well, and so it's interesting that you can see in a period of time, this vegetation gets thicker and thicker and thicker. And I've seen this in the Kettle Lake down by Waterloo. The times that I visited, I think about 3 times now.
Yeah.
The first time, you could see open water.
Okay.
The second time, it's starting to disappear. Now it's a sort of like a bramble brush
Really?
thing.
So what time frame are you talking about here?
Well, 3 or 4 years.
So think about, okay, so that goes back to our other thing too, sometimes how the secular or the standard thing, they stretch out the time, and what you're seeing is how fast things change, and you say, how could these things be around for 14,000 years, or even just 3 or 4 years, suddenly things are changing?
Now keep in mind that sedimentary rock, which is rock that's deposited by water, cannot be dated by radiometric methods. And so by definition, there's very little of that kind of rock here in Michigan. Now if you go up into the Upper Peninsula...
Wait, there's a lot of sedimentary rock in Michigan, or no sedimentary rock? It's all non-sedimentary?
It's all sedimentary rock.
Right, okay.
Except for just a few spots in the northern Upper Peninsula by Keweenaw, where we have some old volcanic stuff.
Right. So I just want to clarify that. I was thinking you said we didn't have sedimentary, and I thought we had mostly sedimentary. Okay.
Yeah, right.
All right,
and that's the case with most of the rocks that you find in geology, is that they're sedimentary rock and they're dated by the fossils you find in it.
Yeah.
And then how do you date the fossils that are in it? Well, by what layer it's in,
Yeah, right.
Okay, so it's a circular reasoning, and we've talked about this.
Pointed that out many times, but it's always good to bring it up again because it's true.
But this is the type of thing that we can do. If you have a volcanic rock now, that's the type of rock that you can find the crystals in it, and these crystals are what you will crush up and send to the lab for dating.
Right.
And they'll have several different dating methods that they use on it. Potassium argon dating, rubidium strontium dating,
Lead,
lead to lead, uranium to lead, and
what's the molybdenum? I can't even get that one.
samarium neodymium.
Neodymium, yeah.
And so there's some of these different things. And
we pointed out some of the flaws in the reasoning on that as well, but that's time for another show.
Well, let's keep it simple here.
Yeah.
Let's say you have a candle, and you come into a room and the candle's burning. And the question is, well, how long has the candle been burning?
Yeah.
Well, then there's some assumptions you're going to have to make. How you have the length of the candle that it currently is,
Right.
the length of the candle that you presume that it was at the beginning, and then you have the rate at which it burns, and so you can sort of observe that.
Right.
So you can see that it burns down an inch in 3 hours.
What you can't figure out is whether the candle hasn't been burning, the candle hasn't been burning for so many hours in between, or somebody took a piece of the candle and put it into another room, cut a chunk off in another room, or, or has it been running continuously since it was new, and your extrapolation for how big the candle was might be wrong too. It might be a 6-inch candle or an 8-inch candle, you don't know. So that's the problem.
That's a vast oversimplification,
Yes.
but we can apply those same questions to the radioisotope dating. And one assumption is the initial state of the rock when it was formed. And you don't know that.
Yeah.
That's the first
Then there's and has the rate of decay been standard?
Right, and
you don't know that.
You really don't know that, and this is they've actually figured out that this is the smoking gun. Is that there is a way that the rate of the decay can be speeded up 1 billion-fold.
And what is that?
Well, it's a certain condition, and they figured these conditions happened during the flood.
Yes.
Certain, so the radio, and if you radiometrically date something from a volcano, like Mount St. Helens, which they have done, and you know the date that this formation was, this ash came.
Yep.
But if you get millions of years of...
Which happens all too frequently. There's been volcanoes in different igneous rock that's been dated from different places around the world, and they're always off by millions of years. They are, definitely.
And John Woodmore, he has written a book about the mythology of modern dating methods. He actually documented where some rocks actually had negative ages.
Oh, really? Yeah.
And so I can't, not quite sure how that worked.
So what you get is what we've also explained, but you throw out the dates that are too young based on your presupposition. You even throw out the dates that are too old based on your, because they've had dates, what, Doug, that are like 40 billion years old. I mean, they have like outrageously long, older than the universe. So they throw those out, and so it's the dates they presume in the beginning. So what kind of science is that really?
Well, here's what they do is that on the form that you use to submit your sample to the lab,
you tell them what date you want.
You can tell them what date you're shooting for.
Oh, crock-a-doodle-doo. That's all I got to tell you about that. Yeah.
So that's a little bit about Michigan geology, and I hope you enjoyed our time. And visit Michigan. It's a great state.
Beautiful state.
To find out and all sorts of different things. We'll see you next time on Revolution Against Evolution.
Yeah.